Good evening. We are in section 1.6, which is over solving proportions. Here is the solve it at the top of the page. You are making beaded necklaces using a pattern in which 2 large red beads are followed by 3 small blue beads. Each set of 5 beads adds 1 1/4 inches to the length of the necklace. How many of each color bead will you need for a 20-inch necklace? Now, knowing that we have a total number of beads, 5 beads, that equals 1 1/4 inches, we can go and figure out how many total beads would I need for a 20-inch necklace. So let's write a proportion. 5 beads would be 1 1/4, which I'm going to write as a decimal. Well, 5 beads equals 1.25 inches, or 1 25/100ths of an inch. So how many beads would I need for a 20-inch necklace? So 5 over 1.25 inches equals x over 20. You can solve a proportion however you would like, but I'm going to cross multiply. This is going to give me 1 1/4 x, or 1 25/100ths inches, equals 100. That would give me the value of x as 80 total beads. But we still need to figure out how many of those are red and how many are blue. So if I look at this problem, I know that there are 2 large red and 3 small blue. That means that's in a ratio of 2 to 3. But all I have is the total number of beads. So I need to figure out how many of those will be red or blue out of 80. So here's how you make your own proportion. I'm going to pick 2 large red. So there are 2 red beads out of how many total beads? The reason why I want total is because I have 80 total beads. So this has to be the total number of beads. So there are 2 large red beads out of a total of 5 beads, because 2 plus 3 gives me 5. So if I cross multiply, that gives me 5x equals 160, and 160 divided by 5 gives me 32, and that gives me the number of red beads out of the total number of beads. So that means I have 32 red, and then just subtract from 80, that would give me 48 blue beads. And that would be your answer. So I want you to read the shaded region to yourself and understand what a proportion is. And let's do the got it at the bottom of the page. The got it says, what is the solution of the proportion x divided by 7 equals 4/5? Now, you've done this before, so this should be review. But you can cross multiply, get 5x equals 28, divide both sides by 5, and that will give you an answer of 5 6/10. So if you need extra practice, you can do the practice 1 and 2 problems at the top of page 53. And if you don't want to do those, that's okay, but the answers would give you for the first one 4 2/10, and the second one will be 2 1/4, or 2 25/100ths. Now let's look at the gray section on page 53. This is the cross products. Now, this is what we just talked about, but I want you to understand the definitions here. So it says, here's why it works. A divided by B equals C divided by D. Now notice that it says under the algebra section that B cannot be 0 and neither can D. The reason is because you cannot have a fraction dividing by 0. That's an undefined fraction. That cannot work. Also make note that in the proportion, A and D are called the extremes, and B and C are called the means. So it's something I just want you to be familiar with. I now want you to turn to page 54 at problem 3 where the got it is. It says, what is the solution of the proportion n divided by 5 equals the sum of 2n and 4 divided by 6? You are still going to actually cross multiply here. So we're going to take 6 times m times 5 times 2n plus 4. Now you can skip the step I'm going to write down, but what you're going to be doing is distributing that 5 into that 2n plus 4. So you're going to have 5 times 2n plus 4. So if I distribute that, that's going to give me 6n equals 10n plus 20. So now I need to isolate the variable on one side. So I'm going to subtract 10n. That would give me negative 4n equals 20. Divide both sides by negative 4. That would give me a value of n equals negative 5. Let's now do the practice A problem, number 5, at the top of page 55. We have q plus 2, the sum of q and 2, divided by 5, equals the difference of 2q and 11 divided by 7. Let's cross multiply. But this time, let's skip the step. Let's actually distribute, because you guys can do that. So let's distribute the 7. 7 times q plus 2, what would you get? Be 7q plus 14. Distribute the 5. 10q minus 55. Get the q's on one side, so I'm going to subtract the 7q. That would give me 14 equals 3q minus 55. Now I'm going to add 55 to both sides. That gives me 69 equals 3q. Divide both sides by 3. That gives me the value of q as 23. Now notice that I'm skipping steps here. I am actually, like for example, the minus 7q plus 55 divided by 3 divided by 3. If you are comfortable skipping those steps, that's fine. But if you're not, I still want you to show those steps. I want you to get used to showing those steps before you start skipping them. So be 100% sure of yourself before you start skipping those steps. I now want you to pause the video and read the gray section about real-world situations with proportions in the middle of page 55. So now we're going to do the got it under problem 4. It says an 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in a 12-ounce can of orange juice? So pretty easy. The first sentence tells us our first proportion. We know that we have an 8-ounce can, and if you want to put the labels, you can. And 8 ounces of orange juice contain approximately 97 milligrams. We want to know how many milligrams, so that's going to be X, of vitamin C are there in a 12-ounce can. Solve that equation yourself. If you solved it yourself, you would get 8x equals 1,164. Divide by 8. You get 145 and a half, or 0.5. Please make note, this is a word problem. We have to have a label. How many milligrams are there? There's approximately 145 and a half milligrams in a 12-ounce can of orange juice. I want you to do the practice number 7 gardening problem at the top of page 56. If you did that problem correctly, it would take you approximately 2.5 hours.